Hi, in this video we're going to learn about logarithms. So we have came across exponential functions. Exponential functions has a general form of a to the power of x is equal to b. Right, this is exponential functions, and we know that there are a few conditions, right? There are a few conditions where my a has to be a positive value, which means my a has to be greater than 0, and also my a cannot be 1. Right? If my a is negative, then my exponential function is not going to be valid. Okay, or if my a is 1, then also my exponential function will not be valid. All right. So now we've learned about exponential functions. Now let's take a look at logarithmic functions, or people call it logarithms. Okay. So here I have 2 to the power of 3 is equal to 8. That is in exponential form. Let's say today I don't know 2 to the power of what gives me 8. Let's pretend that we don't know what that is. We don't know what the power is. So logarithmic functions can help us to solve this, right? Because if I do this, if I say log, for now you might not be able to understand what I'm doing here, but I'm just showing you guys kind of the general idea, right? General idea. Log 2. So I'm going to log both sides, right? I'm going to log both sides. Okay. So, and when I log both sides, we'll be talking about the individual parts of the log later on. But for now, what I'm doing here is just I'm taking the log of both sides, right? And then if I do that, I will get on the left hand side, I only have x. On the right hand side, I'll get 3, which is my exponent. Right? So ultimately, the log functions, the logarithmic functions, they can help us to find the exponents. Right? They can help us to find exponents. When we were talking about exponential functions, I mentioned that all this time, right, before we got to this chapter, all this time my variable is always something like x squared minus 2x plus 1 is equal to something, right? So my x is always kind of the base, right? Right now, when we talk about exponential functions, my variable is actually the exponent, right? So sometimes, and most of the time, we do have to find what's x, and which is the exponent in this case, and that's when the logarithms come in handy. Okay, so this is the reason why we need to know about logarithms. Okay, so there are a few properties, just like the exponential functions. Exponential functions have some properties, right? Some domains, range. If you're not sure, please refer back to the previous video. We also have some properties about logarithms. Right, so let's take a look. Now I'm gonna start by looking at the graphs. Right. So if you have internet access, feel free to open Desmos and then put these two equations in. I'm gonna erase the top. All right. So if you open Desmos, you can see the graph. You can see the graph of y is equal to, say, 2 to the power of x, right? And the next equation, I want you guys to try this. Y is equal to log. X is there, but the bottom has a 2. Okay. So how do I call this? I call this. This is called. This is how I pronounce it. Log x to the base of 2. To the base of 2. Okay. Because the base is here, 2, So that's why the base is, when I convert the equation from exponential to logarithmic, the base stays the same, right? So here in this case, my base is 2 in both my exponential and logarithmic functions. Okay, so just go ahead, put these two equations in your decimals, and you can see that this is your y is equal to 2 to the power of x, right? And you should be able to see a horizontal asymptote for your exponential. All right. Now for your log graph, it should be like this. It should be like that. Oops, sorry about that. It should be like this, right? And for your log graph, you will have a vertical asymptote here. Vertical asymptote for your log graph. All right. Now, I want you guys to look more carefully on your graph. Look more carefully. Do you see some kind of symmetry somewhere? Some kind of symmetry. Right. Feel free to pause the video and look at your graph. Do you see some kind of symmetry? There should be. There should be some kind of symmetry. Right. So I'm going to tell you guys the symmetry is here. These two graphs, the graphs of 2 to the power of x and the graphs of log x to the base of 2, they are reflection of each other across y is equal to x, right? They're exactly the reflection of each other across this y is equal to x line. Now, what does that mean? What does that mean? We talked about this earlier on, right? In chapter 1, where we talk about functions. When the graphs are reflection of each other across this y is equal to x, that means they are inverse of each other. They are inverse of each other. Right? Inverse of each other. And this is an important relationship, okay? This relationship here, it is very important. So if they are inverse of each other, then what, right? Then what? Then that means when I put, let's say today, if my f of x is equal to 2 to the power of x, and let's say my g of x is equal to my log x to the base of 2, right? If they are inverse of each other, then when I put my g in my f, I'll get 2 to the powers of my x. My x is no longer x anymore. My x became g. So 2 to the power of log 2x, right? And let's say if I put my f in my g, if I put f in g, I'll get log x on this x now is no longer x. That became 2 to the power of x, right? So here, what I've done is I've put g in my f, and I've also put f in my g. So what I did was I put them into each other, and because they are inverse, my answer for both is always gonna get x. Right? My answer will be x. Another way of saying that is because they are inverse of each other. So when you put them into each other, does not matter who is in who. They kind of cancel out. You can kind of think of this as canceling out, right? You can kind of just, that's gone and that's gone, like that. You can kind of think it that way. But because they are inverse, they actually undo each other, right? That's what's actually happened here. They undo each other, right? So we will always get this x. So just now, when I show you guys this example, you guys might be wondering, how did I do this? How did I get from this line to that line, right? How could Mr. Henry do that, right? So this is the reason why, because they are inverse of each other. So when I put the log when I log left and when I carry out a log operation on the left and on the right. So here I have exponential inside my log. So because they are inverse, they cancel out each other, and that gives me only an x. Right. And on the right hand side, we'll talk a little bit more about that. Okay. So how do I know that log 8 to the base of 2 is 3? How do I know that? Maybe some of you guys already kind of get it, right? Maybe some of you guys are able to guess this. Now, if I want to know log 8 to the base of 2, I don't know what that is. Let's say that is equal to w, right? And which is the value here, right? Because if I know what my w is, then my value is going to be that. So right now it seems like my w is 3. But let's pretend that I don't know how did I get that 3? So we need to, in order for us to do this, number one, we can use a calculator, right? The calculator can find the answer for us, or we can just convert this. We can convert this into exponential form. Right now, what I have here, this is in log form. I'm going to convert this to exponential form, right? So this is log 8 to the base of 2. If I convert that, then the base is 2, right? So I'm going to write the base. The base is 2. What does the log give me? This value here, what is that? I mentioned that just now. That is my exponent, right? Every time when I take the log, it will give me the exponent. So 2 to the x, this is my exponent. This is my exponent. Right? So my exponent is going to be w. And the 8 goes there. So basically what we are saying is 2 to the power of 1 is equal to 8. Right, 2 to the power of 1 is equal to 8. So I can change this. 2 to the power of w is equal to, so 2 times 2 times 2, so 2 to the power of 3 is equal to 8. So my w is equal to 3. Right? And that's how we got this 3 here. Okay? Alright, I'll show you guys more examples in the next video. But for now, I hope you guys see the relationship between my exponential functions and my logarithmic functions. Alright, good luck. I'll see you in the next video.